Hello student, in this proceeding lecture, I will start the problem based on the series and parallel circuit of diode. So this is the next lecture of unit 1. So let's begin. This is the example 1. In this example, for the series diode configuration shown in figure, determine the VD, VR and ID. So in this lecture, I have to calculate what is the VD across this diode and what is the voltage across this resistor. And along with this, I will also calculate the current flowing in this whole circuit. So what we have to do, we have to just see the condition of diode may be in forward bias, diode may be in reverse bias. So all those conditions we will govern, and we will see what will happen inside this circuit. Since the applied voltage establishes a circuit in clockwise direction to match the arrow of symbol, and the diode is in on state. What is the meaning of this? Here we can see 8 voltage has been applied across the diode, and positive terminal of 8 voltage is the P in the P side, and negative terminal towards the N side. So definitely this diode is in forward bias. So this is the silicon, and we have to replace this silicon diode with their knee voltage. We know the value of knee voltage of silicon is 0.7 volt. So this is the 0.7 volt at the place of diode. Now we have two source of voltage. One is battery, second one is diode voltage, and one resistor. So VD is 0.7. So from here we can calculate VD is 0.7. One parameter we have optimized. Now for getting VR, we have to calculate current in this resistor. So what will the resistance? Resistors will what will the current? Current will be total voltage upon resistance. So what will be total resistance? We have to apply KVL. So we will start this from this diode. This is minus 7 volt. Then current, if current is flowing inside this resistor, is ID. So minus 2.2 into ID plus 8 volt. This is the total voltage in this circuit. Now we have to find ID, and ID equal to 3.21 milliampere. 3.32 milliampere. This is your ID value, and VR equal to R into ID. So from there we can calculate 7.3 volt. So this is the very simple example in which diode is connected in series with resistor, and we have to calculate all this voltage and current. In the next example, let me start in the next example. Determine ID current. ID current means here in this circuit, and VD2. VD2 means the voltage across the second diode, and V0 for the following figure. V0 means that here at the right side we have to calculate these three parameters. So what we have to do? We have to assume first. So ID will be what? What will be ID? Let's see. Plus 20 volt has been applied here. So first this diode. Let me take a pointer. Then you will get understand easily. This diode, this one, will be forward bias. Okay, means it will be short circuit, or it may be replaced with 0.7 volt. But this one will be reverse bias. Second diode. If this diode will be reverse bias, then it will be open circuit. Then there will be no any kind of current in this circuit. So ID will be 0. Okay. So V0 will be what? ID into 5.6 voltage. So ID current is 0. Then definitely the voltage across this resistor will be 0. So here we will get 0 volt. Okay. So now what will be the next? We have to calculate VD2, because here it is open circuit, and we can calculate easily VD2. How we can replace this circuit? Plus 20 at this is the battery. Now second one will be diode VD1. Let's assume the voltage across the diode is VD1, and the VD2 is the voltage across the second diode, which is open circuit. And now this is the circuit. Now we can apply KVL. In KVL, what will be the plus 20? First, what we have to do? the the sign of the voltage will replace with the opposite. Means if we will pass through negative terminal, we will write positive, and when we will pass through positive terminal, we will write negative. So plus 20, because minus 20 is there, so plus 20 minus VD1 minus VD2 and minus V naught equal to 0, because total algebraic sum of voltage equal to 0 according to the Kirchhoff voltage law. Now from this equation we have some value like what? VD2 we will take on towards another side, and now 20 minus VD1 minus V naught. V naught equal to 0 we have already calculated, and VD1 is in the ideal case will be 0. So 20 minus all 0. So VD2 will be 20 volt. So this is the circuit we have to draw accordingly, and we have to calculate all these parameters. Now in the next example, what we will do? This is the circuit diagram. In this example, what we have given: one battery of voltage 10 volt is connected to diode, parallelly connected to diode, along with in the series with a resistor. Okay, so in this circuit, what we have to calculate? We have to calculate current flowing this resistor as well as current flowing these diodes. Okay, ID1 and ID2. So this is the what we have to calculate. If we redraw the circuit according to the knee voltage of this diode, what will be the circuit? Circuit will be like this. This is the battery which is connected like this, and resistance value 0.33 kilo ohm. Now diode will connected here 0.7 volt first diode, second one will be also 0.7 volt. So what we have to do? First apply KVL in this first loop. This is the first mesh. In this mesh we have to apply KVL. So what will be the value? Let's see. Minus E means plus E. Plus 10. We will start from here. Plus 10. Then minus 0.33 into I1. Minus 0.33 into I1. And then minus 0.7 equal to 0. Here we can see. So from here we have to calculate I1. I1 equal to 28.8 milliampere. I1 we have got. Now what about ID1 and ID2? We know this I1 is flowing these two circuit, and both these two circuit, this one and this one is identical. So ID1 will divide into half and half. Okay, so ID1 and ID2 become equal to I1 by 2. So here we have to divide 28.8 with 2, and we will get the answer. So this is a basic question, you can understand easily. Now in another example, determine what current? I current here, and second thing V1 across this resistor, V2 across this output resistor, and V0 is here at this point. So these are the parameters we have to calculate in this circuit diagram. So before going to calculate, we can redraw the circuit diagram in this way. Here let's see, E1 is equal to 10 volt, so 10 volt battery will connect across this resistor, and silicon will replace with their knee voltage 0.7 volt, knee voltage, or we can say built-in voltage 0.7 volt, and this resistor is connected here. Okay, and resistor with connected along with this, what is the value? This is the minus 5 volt battery. This is E2 is minus 5 volt, so we can change minus 5 volt with the battery like that. Negative terminal will be this side and positive plate will be this side. Okay, now we have to calculate all those parameters. So we will apply KVL in this mesh, or we can say in this loop. Okay, so what is the KVL? Sum of all the voltage will be 0. This is the theory of KVL. So here 10 volt battery resistor and 0.7 volt battery and another resistor, so we can add all these voltage. So we will start from here. minus 4.7 into I in this register, because current is flowing like this, so minus will start. Minus 4.7 into I, now minus 0.7, then minus 2.2 into I, plus 5, then plus 10 and minus 10 here. Okay, this minus 10. Now what we can do? From this equation we can calculate our current, and current equal to 2.07 milliampere. We have got current, so what we can calculate? V1 equal to current into 4.7. We can calculate V1. V2 equal to current into 2.2. V2. Now what? Now V naught we have to calculate. V naught equal to what? This is another loop. Here, like this you can see. This is another loop. We have to calculate K naught. I1 V naught minus 5 volt here, and plus 4.55 like this. So here you will apply KVL in the second loop, and we can easily calculate V naught is equal to minus 0.45 volt. Minus sign indicates that V naught is polarity opposite that the appearing in figure. Minus sign, what is the meaning of minus sign? Minus sign means it is not like this. It is just like this. This is in this way V naught we can calculate. This is the meaning of polarity. Our next example, determine the I1, I2 and ID2. Okay, so what is the way? We have two loop and we can individually apply KVL, and if and easily we can calculate all the current like in the previous manner. Okay, now example 5, find the current I. Here we have to calculate I. Replace this diode with 0 volt, 0.6 volt, 3 volt. We have apply KVL in this loop, and you can easily calculate. Very simple question. And what is given? Find the current through the circuit using characteristic equation of diode. Oh, by using characteristic equation of diode. Actually, here one thing is given, that we have to use ID current formula. ID is equal to ID naught or I naught e to power V upon eta Vt minus 1, like that. So here reverse saturation current is given. Voltage across this diode, these two diode is already given. Okay, so first current we have to calculate this. Second we have to calculate this. Both current will be same. Okay, so from any equation we can calculate. And what is given? Voltage of each diode is 0.6 volt. So voltage is given, and reverse saturation is given, and silicon about neta there is no information, so we will take 1. So using that formula we can easily calculate the current. Just try it by yourself. Okay, this is the way how we will calculate. Just see the and try. Okay, this is the solution. Actually you can see it. Next question is this. Take solution. This is the solution. Next question is this. See the solution. Just see and try. All this question is given because this is important question. Okay, in one video not possible I will solve all the question, so you have to see and try by yourself. So this is all about today lecture, and I will start at the topic in the next lecture. So thank you so much.